So in the previous video, we learned about how you can count in organic chemistry, right? So moving on, today's topic is detailed study of group 1. So this is the first family that we'll be talking about. Right. And of course the name of the family, as I've taught you, is the ending, which is the suffix, and it is A. So we'll talk about alkanes, right? Now they are also known as hydrocarbons, right? So we learn why they're known as hydrocarbons, but this is just you could say it's an introduction to what alkanes are, right? Okay. So since we've mentioned hydrocarbons, let's understand what a hydrocarbon is, right? So this is the first family, and the first family for us in this case is for our alkenes, right? And alkanes are also known as hydrocarbons. So what are hydrocarbons? Let's see. So those are organic compounds which contain carbon and hydrogen only. So organic compounds are those compounds that contain carbon, as if you remember, except the exceptions that I've taught you in a lot of detail in the previous video, right? So what are hydrocarbons? These are those organic compounds, so they already have carbon, but along with carbon they also have hydrogen. So what are hydrocarbons? These are those organic compounds that contain carbon and hydrogen only, right? Okay. So we'll be moving on to the study of alkanes, their detailed study. So we've learned that alkanes are known as hydrocarbons, and what are hydrocarbons? Hydrocarbons are those organic compounds which contain carbon and hydrogen only. So they don't have anything else other than carbon and hydrogen. Right? So that's why they're called hydrocarbons. See, hydro comes from hydrogen, carbon is carbon itself. So hydrocarbons. Okay. What is the general formula of alkanes? It is CnH2n plus 2. right? So what is this all about? We'll soon find out, right? So for any alkane from the first till the last, the general formula will be CnH2n plus 2. Now, what is this formula about? Why is it so, uh, why does it look so difficult, right? In like, actually, it is not like, but it's just like something that looks complex, right? Now, one other thing before I move on to the general formula of alkanes that we need to know is that in alkanes, this is all you're going to see. All we're going to see is carbon-carbon bonds and carbon-hydrogen bonds. Like I've taught you, hydrocarbons, right? Why are we calling them hydrocarbons? Because they only contain carbon and hydrogen. So there are two types of bonds that you'll be seeing. Carbon and carbon, because you already know that carbon can form a bond with itself, right? Hence they can undergo catenation that I've taught in the previous video, right? And of course they can form a bond with hydrogen as well. So these are the only bonds that you'll be seeing. Now let's discuss this formula. Now what is this formula about? We'll go one by one, but before I start discussing the formula, you need to know N stands for the number of carbon atoms. N stands for the number of carbon atoms. Okay, everything's going to make sense once we begin our journey, right? So you need to keep this formula in mind. Now we need to go from the first to the last, so we'll make a proper table. Your table should look something like this, right? On this side, you write down alkane members. On this side, you write down molecular formula, and on the very last side, you'll be writing down the structural formula, right? So it should look something like this, right? Okay. So alkane members molecular formula, and then structural formula. Now I've taught you how to count in organic chemistry. So we start with meth, then eth, prop, bute, pent, hex, hept, oct, non, and dec, right? So this is the prefixes that you'll be seeing with every family. Now the ending, which is ane, will tell us, right? In this case it's ane, in other cases it's going to be different. Tells us what family the organic compound belongs to, right? So we'll start out with the first one, which is meth. So meth, I'll just write down C. Meth means one carbon, and with meth I'll put down ane, right? So this is the first member of the alkane family. How did I find it out? Simply by remembering the counting from the organic counting that I've taught you. So meth means one carbon, right? And ane would be the family name. So this is the first member of the alkane family, right? It's pretty simple. I just put out ane with meth and I found out it's methane, right? Now, this part may be easy to understand. What is the part that we need to, ponder over? So, molecular formula. How will it look? How would its molecular formula look like? So, we'll apply the formula CnH2n plus 2. Okay. Now, how do we do this? What has this formula got to do with us? We'll just apply it right now. Now, Cn H2N plus 2. How does this work? Pretty simple. Now this N means the number of carbon atoms. N stands for number of carbon atoms. So in case of methane, as I've taught you, meth means one, carbon, right? A is the family name. So therefore we already know that the number of atoms that methane has is 1. Why? Because N stands for the number of carbon atoms, right? N is simply like it's like N means something, right? Like um, how do I put it, right? Like the traffic lights. You know that red light means you have to stop. Orange means that you need to get ready, and green means go. You already know this, right? Red means stop, green means go, orange means that you need to get ready and you need to take off. So each light color symbolizes a specific action. Similarly, N symbolizes the number of atoms that the organic compound is going to have, right? In this case, it's meth. Meth means one carbon. That means that N is going to be 1 in this case, right? Now, this we're going to do some basic maths. So C1, I'm constructing the molecular formula for methane. So C1, then H2 brackets 1 plus 2. This 2 goes with this 2N, right? So don't confuse it as being what we call being separate. Okay, so let's go. So C1, then 2 ones are 2, 2 multiplied by C. If something is in brackets, that means you have to multiply. The 2 multiplied by 1 is 2 multiplied by 1 is 2, 2 plus 2 is 4. C1H4 is the chemical formula for methane. Now in chemistry, um, it's a general rule, right? Like I've taught you before as well, that you don't mention the 1. If there is nothing there, it already means 1. Like when I taught you about chemical formula, if you remember, right? H2O. You don't write down. You've never seen people write down H2O1. Although everybody knows that there is one oxygen atom and 2 hydrogen atoms, but still nobody writes H2O1 because that is wrong. That is a wrong chemical formula. And in this case, you don't write down C1H4, you write down CH4. CH4 is the molecular formula for methane. How did I do it? Simply by replacing N with the number of carbon atoms. So in this case, N, here was 1, here it was 1. So 2 multiplied by 1 plus 2 is what? 2 multiplied by 1 is 2, 2 plus 2 is 4. So H and 4 go together. Very, very easy, pretty simple, right? So methane has the molecular formula CH4, and how did we find this out? By simply learning its general formula, which is CnH2n plus 2. With this formula, you can find out the molecular formula for any member of any organic compound. For any member of the alkane family. Sorry. I was being too, taking things into a broad spectrum. So with this, you can find out the molecular formula for any member of the alkane family. Now, the structural, how does it look like? If you remember, I taught you about Lewis structure. So structurally, how will methane look like? How are you going to present it? Simply by placing carbon at the bottom and 4 hydrogens on all sides, because we know carbon has the valency 2, 4. So that means it can form 4 covalent bonds. It can share 4 electrons with another atom, right? So it shares one with this hydrogen, one with that, and one with that. And this is the structural formula for methane. So you can call it methane. Some people like to call it methane, but if you're more specific, or you can even say methane. All right. Okay. Let's move on to the next member of this family. So see now the member that is going to be on the second place will be, of course, having two carbon atoms, because we know with the counting, organic counting, that it's eth means two. So I'm going to put eth, and then I'm going to put ane. So it's going to be ethane. Now, see how am I doing this? I simply remembering the counting. Meth means one, eth means two. So the member that's going to be on the second slot will have two carbon atoms, and the name would be ethane. Okay, chemical formula, similar, same. We're going to use the same formula, CnH2n plus 2. See now N here is 2, right? And N here again is 2 plus 2. So the formula that we'll get is C2H6. Now 2 multiplied by 2 is 4, and 4 plus 2 is 6. So C2H6. Now 2 is something that you have to mention if it's there, so you just can't, erase it. So ethane is C2H6. Simple. Just use the formula. See, N is replaced by 2. So C2 is checked, right? C2 is checked. It's not that difficult. Maybe you might be confused about how we find out the number of hydrogen atoms, which is also very simple. All I do is I replace this N with the number of carbon atoms. In this case, it's 2. So 2 multiplied by 2 is 4. 4 plus 2 is 6. And this is how I get the number of hydrogen atoms for ethane, right? You just have to use this formula that is above and find out the molecular formula for any member of the alkene family. Now, how are you going to make the structural formula for ethane? It is also pretty simple. See, actually what I'm going to do is I'm going to draw it like this, so because I have less space. So two C's together. See, now carbon and carbon will form a bond with one another because it's C2H6. Therefore, the carbon atoms in together they form a bond between themselves as well, because it's C2H6. It's not CH4, it's C2. So see, one bond for each carbon will be utilized. So how many are we left with? 3 on each side, right? So if you do the maths, 3 plus 3 is 6. Therefore, each carbon atom can now form 3 more bonds, right? So this is one way of counter checking. So one up, one here, one here, one here, one here, and one here. This is the structural formula for ethane, right? Pretty simple. Carbon and carbon can form one single bond with one another, that we've learned before as well. And the rest hydrogens can form a single bond with the 3 valence electrons that are left. And how did we find out the molecular formula? By using this. So N is replaced with 2C2, that's done. 2N plus 2. Now N again is replaced with a 2. So 2 multiplied by 2 is 4, and 4 plus 2 is 6. And therefore, this is how we find out the molecular formula and the structural formula for ethane. So the rest, if you've understood up till now, the concept is crystal clear to you. The rest you can even do by yourself, but we'll do them in the class, so we're having no errors. So I've got a little bit lack of space, so I have to rub this off, all off, right? On the other hand, of course, you have to construct your notes so you won't be rubbing them off. Three is, see now, the third one will be prop A, right? Because on the third, you've got prop and the family name is A, so prop A, right? Prop